All right, so from the starting onwards, I'm going to give you basically a guidance. What are the books, what are the materials that you're going to follow for this classroom trainings, or could be for the online trainings also. The one that you have to really go through would be www.cisco.com/go/ACI. That would be the way that you would be going to a particular technology links from Cisco. Most of the time it will be cisco.com/go. You can write on UCS, you can write on ACI, and even you can even write on Nexus. Now, we would be trying to understand what is all about application-centric infrastructures. Obviously, most of the candidates over here who is participating in this bootcamp, they have a good understanding from the real scenarios, how we build any kind of infrastructures, what are the problems that we do face. Main thing is that we are trying to solve those kind of basic building blocks issues that we might have faced in infrastructure building. But yeah, this is the first thing, like you can just follow right now. Application-centric infrastructures, ACI anywhere, that is the terminologies like most of the sales guys follow while making a sales kind of scenarios. But mostly the idea is that we want to give SDN infrastructures to the customers. So though like we had got a lot of number of SDN product line, but from Cisco, this could be the best answer what I can tell you. So what it does offers, first thing is automation and agilities. Obviously, automation is one of the very key things that's been coming up in the industry, and how we are trying to achieve. We'll try to take a look on it. And obviously like open programmable, because if you'll be seeing most of the trends, maybe if you might be following LinkedIn, or if you might be following the new technology enhancement, it's the talk of programmability that we really talk about nowadays. So it could be a network programmabilities, and accordingly only we are trying to build and research on the new kind of operating systems. So whatever the operating system that you do see, that's been running on the hardware, which could be on Cisco routers, could be on switches. Even when you talk about on Junipers or even on Arista, they are trying to make that kind of OS which can receive some kind of programming skills. I'm sorry, anyone was talking? All right, so I think, yeah, I'll just expect that if everyone can mute from their end, if they have any query, they can actually put the questions on the chat box. If I'm not able to grab your questions, you can just unmute and you can query your question. I think, thank you, Kishore. Yeah, so I was talking about on the open and programmable. Obviously, we are going to talk about what kind of programmability's ability we are going to get it out from ACI. Obviously, security and analytics. This is also one of the very key features that's been coming up. Like we provide security, but what is the analytics play that happens at the back end? We need to even understand that stuff. But obviously, from an infrastructure basis, we know that the key fundamental of things would be a security that we should apply, but how proper way we can apply that security without doing a lot of number of hands-on and making a lot of number of changes in the configurations. Like there would be some sort of artificial intelligence you can think about that's going to play the role, and we are going to apply the securities on it. Obviously, the other thing is the mobility, workload mobility. We never will know that where our workloads would be there, because as we are building the data centers, it's not only located at one locations. It might be extended to the another locations of data centers, and we need to have proper scenarios where we can have active kind of data centers. So what are the key things that comes up we need to really understand, basically from a routing and even from the switching point of view. Obviously, there's a specific report that you can freely follow. I don't want to really waste a lot of number of time on it, but this website does have a lot of number of details on it. Now, coming to the building blocks of ACI, whenever we talk about, it's purely on the Nexus 9000 series switches where we build these technologies. So usually like this switches can work as like a per box programmability devices, or maybe you can go with as a bulk or a bunch of number of switches where we can configure it in one shot. So that's the answer from Nexus 9000 that you were going to see. We'll see what are the different hardwares that we can follow for the ACI modes. The next thing, which would be the APIC, like when you really see most of the networking fundamentals nowadays, there's a keyword that's being called as controller. So what is ultimately a controller from Cisco's answer? We'll try to figure it out. Ultimately, this is going to be called as APIC. Even in the another technologies like in DNA centers, we call it as APIC-EM. And when you do see some another vendors, they do also have the very similar kind of logics like controllers. Now, the another thing that comes up earlier, it's being called as AVA switches, but nowadays they have enhanced that skills and they call it as ACI virtual edge. It's again like in a virtual world, how we are trying to push down our policies by which the workloads which is being running in the VMs level, they can do the routing, they can apply the securities, but that has to not go up to the levels of to the securities or to the switches level. So we'll try to see up to an extent ACI virtual edges. It's one of the very new feature that has been enhanced from Cisco ACI. But I would be telling this is just a naming convention that they have changed earlier. It was called as AVA switches. And other things like more like from a case studies, what are the different partners, how we try to deploy the ACI networks, basically like building a DC fabric from a greenfield environment, or sometime when we have to migrate from maybe from the environment of Catalyst or iOS to the ACI infrastructures. Similarly, like how we migrate, there are many kind of case studies that you can get a look. Obviously, there are a bulk number of white papers that is being available, and that's going to be always a good documentation that you can use it for your projects, where in your project wherever like ACI is going to come up. Now, the other thing is like automation should be a simple. So we know it's one of the very basic pain point of most of the network engineers nowadays. Like they might be claiming that earlier I was doing OSPF, EIGRP configs. Now suddenly I have to go into the automation world. I must be telling, yeah, we have to move, but obviously Cisco is going to help us a lot. Maybe with the answer of UCS director. So, and probably in the data center studies, you're going to see what is the meaning of UCS director, how it is going to provide automations. But ultimately, like we are trying to build that kind of infrastructures which can receive any kind of automation scripts, which any basic user can also create it. At least he should have an understanding on the infrastructures. So we need to really go to the depth levels of creating the scripts, but at least you should know how to run that scripts and apply in your any kind of projects. There are many other things, guys, so I would recommend take a look on it. There are different centers like app centers where you can find out the different ACI related apps which you can actually put in your mobiles, which can actually use it for your management of your whole infrastructures. Similarly, like you can get some smaller videos on ACIs to know about some small key features that's been running at the backend. The other thing that's been coming up in ACIs with the new releases is the multi-site, how we are going to make 2 data centers as active, and how the traffic is going to flow. Obviously, there would be a demos that you can take a look from the demos wise. I would even give you the ideas from where you can actually use the Cisco's lab that's been called as a D-Cloud labs and get more understanding on it. And even like there are other set of products which is being also aligned to be implemented as side by side with Cisco ACI's project. Like one is the Cisco Tetration, which is called as a analytics softwares that is going to analyze the whole infrastructure bundle traffic, and accordingly only it is going to guide you what kind of policies that you should be writing it out. So it's one of the really revolutionary product that's being now enhanced, or you should be telling now going to be put more into the new coming projects that's been coming up from the Cisco side. Similarly, there's Cloud Center. So it's one of the must thing stuff that you should always take initialization from your studies wise, what is all about this stuff. Obviously, this is one, again, I should be telling a good answer from OpenShift. That's one of the way of implementing any kind of app engines in your infrastructures. So there are a lot of things, guys. So that's one thing as a good answer, which you can find out a lot of white papers from an ACI's point of view. Now, coming to the books, I highly recommend that you should follow one of the book, which I guess I'll just show you, which even I had followed for a while. This is the one. This is actually Cisco ACI cookbook. Why I really recommend this book, because it does give you a full like process things in a very easy manner, very easy language that you can drive this particular book. You do find out every topic has been covered very properly, a proper set of configurations, what are the steps that you should follow. Probably that might have been given in 2.x version. Right now we are in the 3.x version, but there's a lot of number of difference. So I would recommend you should take a look on it. But if you want to go to the insight of the policy driven data centers, like what is all about policies, and that is the thing that we will be talking in this whole boot camp. Policies we might be knowing, like from the networking world, it's mostly being applied in the quality of services, maybe on security levels, or sometime on the routing switching levels also. But this time the policies which we are trying to create, that is purely on a data centers, might be it could be for making basic connectivities, might be it could be providing security things, or maybe sometime to provide the load balancing as a services. So the first one is the best one. I should be recommending Cisco ACI cookbook, and the other one which you can even follow from Cisco's, that's being called as the policy driven data centers. The other thing that you can even follow would be the VXlan book from Cisco, because anyhow on the ACI's backend, it's all about the VXLAN or the EVPN that is being running up. So how these things are being added up in your infrastructures, what are the backend configurations which is being put, you can actually get an insight of it by going with these specific VXLAN EVPN books. I guess they have, let me show you this one, would be present in Amazon.in. There's a question over here, beginner level. Yes, exactly. It's basically for the beginner level, because I must be telling, when I started ACI, it was one of the very confusing stuff for me. The helpful thing was about this book. I read through the book first. At least I understood what is the theme, what we want to achieve. And then I had followed those specific steps in my demo labs. So after following it, then I try to make like why we should be applying these policies, what are the different infrastructure problems that we do face. And obviously these are the things that you will not see every time. It depends upon every company's, what are the problem and strategies that they have to run. So it's a must read book, but obviously when you want to go to the insight of any VXLAN set of things, because ultimately it's all about VXLAN that is being running at the backend. So maybe this VXLAN, you're going to use it as a bridging, or sometime this VXLAN you're going to use as for the routing. So what's being running at the backend, you can take a look on this VXLAN BGP EVPNs. So it's also a very nice book. I hope you know how to really download the free version. We are always used to it, but yeah, try to read this book. That is the first intention. And obviously the other thing is the always easy stuff for any guys who are going for any kind of implementation, could be the ACI configuration guides. So when you go with the ACI configuration guide, which will be defined as APIC basic configuration guides. So there are different versions that they have mentioned, like one is 1.x, which is a very old one. 2.x, most of the customers are being running this one, and 3.x, which is being like introduced, I think in before like 6 months. So in this book, you're going to find out, it's a book content, what are the different authentication basic configurations, and how you're going to provision your fabric services. So a lot of number of information that you're going to find out onto it. But mostly the stuffs that we're going to do, it's not from a command levels that we have to achieve. we would be using more the GUI, and we need to understand the GUI level things. And accordingly, only we have to try to build the whole infras. So these are the things, guys, that you should be following, but I would be going to follow a PowerPoint. This is one of the curriculum from the ACI's basic boot camps, where we are going to follow step-by-step process, like what is the meaning of controllers, what is the meaning of SDN, and each and everything. So there are a lot of number of topics which is behind of ACI. We'll try to see what are the different major topics. Just to give you a basic intro on it, from a topic wise on ACI's front, it is very must to understand what is ultimately an SDN technology. So SDN is a lot of number of things that is being written as a component, but ultimately from ACI side, what we do get and what we are trying to achieve from there. There's a question, is there anything that we should be following and recommending in the books? Yes, this is the one that I'm trying to talk about, like how the sequences I'm going to follow and how you can really follow that particular book also parallelly. So the first thing is the SDN, what is all about SDN concepts, what is ultimately called as a control plane, what is the meaning of called as a management plane, and what's being called as a data plane. And what were the issues earlier and what we are trying to achieve with the SDN technologies. Obviously, we have many companies who have got different kind of answers from SDN, but Cisco, they introduced the concepts of ACI. So in this stuff, what would be the control plane, what would be management plane, and who is going to play the role of data plane. So we are trying to decouple these kind of functionalities so that we don't find out any kind of problems in the running infrastructures all the time. There's a question over here, is anything that you can follow from the SDN? I must be telling, like when you go with the global level or the global definitions of SDN, there are many number of books that you can find out in the global internet or maybe on the Safari book subscriptions. But I must be telling, like when you try to follow Cisco, their mantra, their fundamentals of SDN is a little bit different what other vendors used to follow. So I don't want to really give you a confusion state when you get started from SDN. Try to follow Cisco first. Okay, and then probably you can make a comparison with the another vendors. Might be next quarter you're going to study about Juniper Contrail, or maybe you want to go with Juniper VMware NSX. Obviously, all have got their own way of defining the SDN. But at this moment, just try to stick with the Cisco's curriculum. I don't see that they really don't define SDN properly, but yeah, they properly tell you about how to really follow their way of defining the SDN and how to configure and use it for your day-to-day tasks in your infrastructure building. But yeah, if you want to follow that, probably I can give you, it's been a long time for me when I read one and couple of SDN related books. Maybe in the next classes, I can recommend you that particular books, but probably I can't remember those right now. So I was trying to talk about the sequences, what we would be following. So SDN, what is all about it? So ultimately, it's all about the concepts of creating the APIC, because over here, the APIC is going to play the role for our control plane and kind of management plane. But I'm going to put a star marked statements on it. I'm going to define ultimately what is all about APIC. If you would be asking me, APIC, it's purely a management plane and it's a controller pushing devices, which will see accordingly that where we should write on the policies, and accordingly only the configuration will be pushed to the respective switches. So the sequence is that how we would be using APIC, how you initialize the APIC for the first time users. Obviously, this is not the thing that you would be doing every day. It's a one-time task. So if you are running in a project, you would be doing this task only once, as similarly like you might have done the stuff for the UCS or maybe for your ASA firewalls. Now, after going with the SDN, we should be understanding what is the backend term of VXlan. Probably I'm not going to go into the very details of VXlan, but we need to really make a basic understanding from a VXlan, how it is being attached in the ACI's infrastructures. Because ultimately, if I'm going to make a communication from one VM, maybe to the bare metal services, and if I try to put them into one EPGs, they might be there in a same VXlan. Okay. Now, how this VXlan is working at the back end, even though you do have different subnets, but still they will be able to communicate. So we'll try to take a look on the VXLAN perspective, what is all about, and what is the complexities of configuring VXLAN also. Because if you are going to ask anyone that, did you configure VXLAN on Cisco devices with the combinations of their control plane called EVPNs, they will be telling that's a lot of number of steps that you have to do. And that complexities are being really handled by ACI. So you need to do a lot of number of backend configuration tasks, which we might be doing with the Cisco's routers and switches a lot. But ACI is going to provide you that kind of automations power on your devices that all this configuration will be done in just one single shot. So I always tell most of the candidates that whenever you study about VXLAN, its first thing is that you should basically know about the basic fundamental of VXLAN, why we have introduced VXLAN, what are the problem that we are trying to solve with VXLAN. But when it comes to ACI, we need to see the things and answer from his GUI level. Like in GUI, we do have many number of components, and we need to understand their functionalities. That is very, very important. Because always remember, guys, Cisco, they really don't want to make the things more complex, claiming that a network guy can only do the networking. It's being a platform where all the guys can really participate, and if it comes to making a communication between two devices, it can be done by any simple users also. So they are trying to make a curriculum where you have to get an understanding from a GUI level. But obviously, when you go with the troubleshooting tactics, you have to have an understanding on the backend side, how the things is being running from a VXLAN, how we are trying to achieve the multi-tenancies in the ACI's infrastructures, which was one of the major goal of ACI's achievements. So we'd be going to understand what are the basic levels of making the understanding on the ACI side. Yeah, I just given the record access to Abdul. Abdul, you can start the recording. All right, guys. So that was the thing that we would go as a next step. The third step that we would be following will be to understand its GUI. Like, what are the different components in GUI that you're going to find out? Like, what is the meaning of tenants? What is the meaning of access policies? And many another stuff also. So it is very, very important to understand what are the different GUI levels. Then if you have made a pacing, like I know at least the GUI, what are the tasks that we can do at what locations, then only we can make our major infrastructure building tactics. And among them, the first and foremost thing that you should be able to understand how to make any kind of infrastructures in VMware world. Ultimately, this is our topic called VMM integrations. Now, VMM integration is not only the stuff with the VMware, because when it comes to the virtualization cloud, it's not only VMware who is providing the virtualization cloud. It's being like Hyper-V, they are also providing, and even in another way, OpenStack is also providing. But as an example and one of the revolutionary product line from VMware, we are going to follow them first. So in a VMware cloud, how you're going to make that things, we will try to make a basic understanding on it. But obviously some of the folks might be not very known with VMware. Some of the tasks that we would be doing, sometime it would be pretty confusing. Like whenever we will be telling DVS or VDS, ultimately it's a similar stuff, but we'll try to take a basic classes on VMware also, because I don't want to make situations where people are just blank and what I'm doing, none of the guys are able to understand. Because I've seen people coming into the Cisco's background, but maybe they might be not having a background of VMware also. So I'm not claiming that everyone doesn't have, but at least I would try to follow this stuff. Now, after making the VMM integrations, it is very, very important to make the integration to the physical world. So we'll try to see how we are going to get connected to the physical world, which could be even Cisco switches, which could be Cisco routers, not only Cisco switches, it could be any another vendors also. Whatever the devices who can understand the concepts of VLANs or the concepts of subnetting, we can actually attach them. So in that regard, we would be trying to cover up the major two topics called as L2 out, by which we will be trying to do the bridging, or you can think about as a switching. So we'll try to switch any bridge network to the another bridge networks, maybe through the ACS fabric. So that is the main thing that we are going to try to achieve with the L2 out. And similarly, when I do have any kind of L3 infrastructures, we'll try to see how the L3 out is going to be configured to it. Now, that's the main thing that we would be trying to see to connect to the physical world, but it's not only the physical world which we need to only get connected. And that's not the only thing that ACI only gives you as a packages. They even give you the another package called L4 to L7 integrations. So which is basically going to talk about how you are going to build your infra and provide the different set of services like load balancers, maybe firewall, and you want to do any kind of third-party integrations. So this is one of the things which you would be going to hear a lot, like service stitching, service chaining, or even sometime L4, L7 integrations, or even sometime third-party integrations. It is all, everything is going to give you the answer like how we are trying to make other vendors to be compatible with my device set of configs. So I don't want to go into the F5 load balancer and do the basic configuration. I can even do that task even by sitting on the ACI's level also. So idea is that make the things pretty easy. Backend, there are a lot of complexity things are being running. At least we'll try to take an understanding on it. And we'll try to build our infrastructures. Now, obviously, when I'm talking about the GUI levels, I'm going to even talk about what is the meaning of EPs, what is the meaning of EPGs, and what is the meaning of contracts. So these are the major terminologies that you're going to follow a lot, guys. And accordingly, only we will try to make any kind of communications. So nowadays, like when we talk about in the basic networking, we always claim that there's a VLAN that is not communicating to another VLANs. But that's not the way that we will be defining in the ACIs. We will define in such manner that there's an endpoint, or maybe this could be an endpoint group that's not communicating to the another endpoint group. So we'll try to take our definitions, what are that basic definitions, and accordingly only we'll try to build our infras. So guys, this is the way that we are going to follow, and accordingly only we'll try to complete our bootcamp. So try to follow the books, and I hope like in the books also they have followed the similar ideas. All right, so if I'll get started, guys, this first sections where we'll talk about mostly on the SDN primer and what is ACI overview. All right, so I have Pratik also. Okay, Pratik, I've given you the recording sessions option. All right, guys, so let's get started first with SDN primer and what is all about ACI overview. So if you might be following YouTube, you might be following Cisco Lives or many other videos, there are a lot of number of definitions. There are a lot of number of things that can really give you the basic definitions. Everyone has got their own way of defining it, but let's try to make the things pretty easy. Maybe some of the guys who might be working in the infrastructures, they know what are the problems that they face. Accordingly, only we'll try to find out the good way of defining an answer to the ACIs. First and foremost thing from the objective wise, what is all about SDN, what is overlay networking primer, ACI overviews and their basic terminologies, and what are the different application language barriers that we do face and how we try to solve that kind of issues. So coming to the first and foremost thing, SDN overlay networking. I hope we might have heard about this stuff a lot. So when you would be talking about the industry trends, so there are a lot of number of vendors who are coming up with this answer. Like Windows, Google, VMware, Amazon, they are all building their own specific clouds and their own way of defining and creating any kind of networks. It's not only this players, even we do find out the rules of DevOps and the rules of public and private clouds that's been coming up. Because ultimately it's the application which we have to host anywhere. And that application hosting has to be agile, it has to be scalable, and it has to be redundant. And with the proper management, that's the main idea of what we are trying to achieve with data centers. So it could be any vendors who is providing data center. That's least matter for us at this moment. What does matter whether my application is in the safe hands or not. So maybe that could be placed in private clouds, or maybe it can be placed in the public clouds. But what are the backend technologies that is being used that really makes a real play, like whether your cloud is scalable or not, whether your cloud is elastic or not, that really makes a very major differences with the another vendors clouds. But when it comes to the networking stuff, when we really talk about, there's a huge involvement of SDN technologies that we are trying to see. And there are a lot of number of players that is being coming up. Now, among them, I must be telling they are industry leading SDN vendors that you do find out. Obviously, you can even find out from the Gartner reports also. So you do find out, you do have VMware, you have Noage, that's being one of the key vendors for your SD-WAN product line. But these are the basic new operational models that is being evolving in the application hosting. Though might be there was a public cloud for a long time, but when you do see public cloud earlier, like 10 years before, and now you do see there's a revolutionary changes and a lot of number of services that has been enhanced to it. Similarly, there are some other services like MongoDB, Cloudera. They have really enhanced and making as per the application what is being needed at this levels. And you might be knowing there's a huge involvement of DevOps models, which can include like Ceph, Puppets, even like you do have other product lines of DevOps, which is making the applications more agile at this moment. But at this moment, like when we talk about mostly on the SDN product line, uh, when we talk about SDN, there are many definitions that comes up. But from a global level, people used to tell that we want to really decouple the functionalities of control plane, data plane, and management plane. Now, to really understand that things from a very basic levels, if you see any kind of routers, okay, when we do have any devices, like we do have one server, we do have a users that is in the cloud that is present. And if they have the communication that is being going through the routers, there are multiple levels of plane that is being involved over here. Like in this router, first of all, there should be a proper management. Maybe that could be done by our console levels, or maybe through our VTY levels, basically from our SSH, or maybe through telnets. But at the back end of this router, there would be some specific protocol that might be running, like maybe it could be OSPF. That's basically called as our control plane. And when it comes to the data plane, it is on the chip levels how their data are moving from one point to the another point. But the idea of SDN is that how we can decouple all these three functionalities. Now, obviously, a lot of vendors, they came up, they gave their own way of developing the things. They might have decoupled everything, but at one moment, we need to see that it's a huge involvement of virtualization that has been coming up, but some of the customers will not go purely onto the virtualization levels. So they have to have hardware itself, and that capabilities probably you can find out with Juniper or maybe by Cisco. So Cisco, they came up with their own way of SDN answer. VMware, they came up, Juniper came up, and even Arista came up. But who is being leading? It all depends about on the basis of the functionalities what they are providing to the end host customers and to their partners. Even it totally depends upon their support levels what they provide us. But we can't claim that what is much better, what is bad. That is not the best way of giving any kind of technology differences. So the idea of SDN is that when we try to see how we can make our management plane very different, and the control plane to be sitting on the another boxes, and similarly the data plane will be sitting on the other boxes. Maybe we can have a redundancies of all these planes one by one. So earlier, a single router was being working, we were sending the traffic through it, but it was a full involvement of a single router to make the traffic flow. Now, there could be a situations where this hardware can fail. Maybe from a best design, you can switch that traffic to the another path. But the idea is that why we would be going with this kind of complexities. We need to always hire a guy who would be a best with OSPF, who would be good with the hardware levels of this routers, and there would be a guy who would be good with the design levels. So the idea is that how we are going to make our applications to be hosted in a very safer hands, and to manage it, to provide the control planing functionalities at the backend, and to provide the data flow with a redundant way. That is the main thing which we are trying to achieve from software-defined networking. Now, in this cases, obviously, as we are claiming all the time the routers as a hardware, now it could be even a softwares. So you can define that things from a software levels. But again, as I was keep on telling, every vendor will try to apply this SDN technologies or SDN methodologies in their own way. So you can't think about like a Cisco's going out of the boxes of hardwares. They would be still going to develop the hardwares, but they want to make that hardwares to known with these kind of backend processes. So that's the main thing that we are going to achieve and trying to make our applications to be hosted with a proper way. So at this backend now, control plane might be running in the different boxes, and they will be running the redundant way of OSPF. Because ultimately what our OSPF is trying to guide us, how to send the traffics. So maybe that could be asked by some another boxes, maybe the data plane that's going to run on the chipsets. So there would be some switches who would be running the traffics, but that switches will be programmed by some control planes, and that management plane will try to define that how we are going to send that traffic from one point to the another point. So management plane will just be you, like how you're going to trying to develop your applications and how you're going to make provide the securities to them. So could be a lot of number of different definitions that we can provide to us, but obviously like this is the whole idea with the SDN that you're going to achieve at this moment. So it's not being only implemented in the data center world, even it is being coming up in the routing switching world, even in the it's been coming in the service provider world also. So how quickly and how the different vendors are coming up with the new product line, it is very, very important for as an end user or an end engineers, we should be aware about what are the things that is being running at the back end. So at this one moment, like the best example could be our open flow switches, which is a software level switches, which can be run on any kind of operating system, but obviously there should be some specific OS which can be given as a support level. They can have the ideologies of defining the control planes and data planes. Similarly, in the data center world or in the SD-WAN world, we do have the two leaders that's being running up in the network virtualizations. One is the Nishira, which is the acquired company by VMware, and now the same project is being called as NSX. Nuage, as well as Workload, or you can even claim we have another company who has been acquired by Cisco, which really purely work on the SD-WAN technologies. So how they try to make the WAN traffics to be optimized and go with the redundant way, that we will be trying to achieve with the network virtualization without any kind of involvement of pure or heavy hardwares. And obviously the programmabilities, that's the one thing that you can even find out. One of the really great thing about some of the another switches that you do see nowadays, like switches could be of any hardwares, but you can write on any particular operating systems to them. Maybe that could be a vice versa also. So different ways that we are trying to acquire over here. But ultimately, the things that we try to achieve most commonly would be the overlay network. And overlay is not the thing that has been really enhanced at this moment. Overlay was being running from a long time. Might be it was being given as a name called GRE. Then later on, we had to provide securities on those tunnels. So we call it as IPsec tunnels. Similarly, the network was growing a lot. We had like a lot of number of remote customers. So we had a different kind of VPNs, might be a site-to-site VPNs or maybe a easy VPNs. But this is all the role play of virtualizations as well as overlay networking, what we were trying to achieve. But what was the major requirement to have overlays in the data center, that we need to understand very properly. So there could be a lot of number of examples to have overlay networking. So if I'll talk about among them, the first and very foremost thing, when you talk about overlay networking, it could be used maybe from between the DC1 to DC2 connectivities. Maybe from DC1 to DC2, we do have a specific service provider. Maybe that could be a multiple service provider. But when it comes to have a specific application that could be run in the infrastructures like in the vMotions. vMotion is a way by which we try to move an app from one location to the another locations. They need to have a proper L2 networks. Now, might be the definitions have been changed nowadays. Maybe they can run even in the L3 networks with the newer versions of VMware. But the idea is that how we will try to make an application to really see on the other side that they are really in the same data center at each other's. So that we are trying to achieve with the help of L2 networks, which we will try to create with the help of overlay networkings. So even though you're present in one location, it would be Chennai and that would be Bangalore, but the network that you are trying to extend might be there with the L2 networking. So ultimately, this is also one of the very great examples of your overlay networking, which we might be using from a longer times. Now, obviously, these things we might have achieved by multiple ways. It could be done maybe with the help of VPLS, okay? Maybe it could be done with the help of ATOM, that is any transport over MPLS. And even in the DC environment, we are being doing with the help of OTV, or maybe it could be with the help of Lisp. Now, the similar things we are also going to do, but obviously when we go with these specific things, they do have a proper design methodologies that you have to follow. And we can have a new inclusion that could be a VXlan at this moment. So when it comes to these kind of configs, obviously there are a lot of number of complexities as I claimed earlier also. Like you have to create a control plane, you have to write on the configurations that should be able to understand that languages, and then we'll try to make that connectivities. But today what we are trying to do, we are trying to make a multi-site topologies. I think the same one I was trying to explain somewhere over here. Yeah, ACI multi-site. That's the one thing that we would be trying to achieve out over here with the SDN technologies at this moment. So the complexities which were like configuring it, a lot of things that were involved, we are trying to solve that kind of problems at this moment. So that's the one thing, guys, that you would try to take a look from a DC world when it comes to DC to the another DC's communications. Now, when we talk about in the intra DC, so this is one of the example of inter DC. But within the intra DCs, you can have a lot of number of cases where you have to create the overlays. Now, anyone who have the ideas that why we should be creating an overlay networking within the data centers? Anyone? Maybe on the chat box, you can write on that things. I'll give you a moment, guys, 1 minute. Meanwhile, I'll just grab a cup of water, okay? And just let me know where, in what situation we should be using overlay networking within the data centers. All right, guys. So I see there are a couple of answers that's been coming up. The first answer is to load balance the application server to have a failover over from a production to a disaster recovery data center. Yeah, exactly. That could be one of these case scenario where we have to move our every workloads to the other data centers. So obviously we should have an overlay networking. And that's been one of the things that we are trying to achieve from DC to DC communications. Now, there could be another question. There's another answer, massive scaling. Exactly. Now, I would be telling like, how many guys have actually used AWS, Amazon Web Services, or maybe you might have used the Google Cloud or Azure Cloud. How many guys have used it? At least they might have experienced what you do get, right? I think Pratik has used it. Anyone? Oh, so it's only Pratik who has been using AWS. Okay, Vishnu is being there in the list. Okay, guys. So I see we have a small section of people. They might have used or they have experienced what the services that AWS provides. But obviously, guys, remember that AWS, what they have done, they have created a lot of number of data centers. So one of the one which you find out in India, they have constructed their data center in Mumbai locations. So ultimately what they're trying to achieve in Mumbai's location. So always take and visualization as in effect, like we are trying to create a public cloud and try to think that we are trying to give infrastructures as a service to the different customers. So let it be in the Mumbai's locations. We have Pratik, we have Venkatesh, we have many other folks like ABC. So they are coming as a different customers and they try to use the same data centers. Now, obviously you as a customer always claim that I need to have that number of EC2s. So if the guys who doesn't know what is the meaning of EC2s, it's actually a VMs that we try to create in the public cloud spaces. Now, there are a lot of number of advantages of public cloud as compared to private cloud. We don't want to really go into that things, but what we are trying to achieve with ACI is to create the similar kind of infrastructures. Like if anyone as a customer can use the same infrastructures, what the another customers are being using, but their applications, what they have hosted might be very different to the application which is being hosted by the another customer. They will never interact to each other's ever until unless there's no any kind of requirement. And the similar things is being done even by the AWS guys also. So thinking about like Pratik might have created a VM number 1 in his location, and it has provided elastic IPs, and then it is being going to the outside world. So it is being a hosting that is being done on the these particular infrastructures. Similarly, we have VM2 that might be created by Venkatesh, and might be we have created a direct connect, or maybe they have created a IPsec VPNs to their on-prem devices, and that's being hosted also with the same way. But remember, guys, all these things is being running in where? They are running in the same infrastructures. So you never ever know that they might be sitting on the same servers, all these VMs, backend virtualization. They might be using some backend virtualizations. But as an end user, you are not being exposed what is being running at the backend. So that's the beauty of public clouds. But when it comes to creating a private cloud, we need to know about those kind of scalabilities, how it is being achieved, and how we try to segment that traffic with the one customers to the another customer. Because ultimately you're sitting on the same boxes, but you never ever know that there's another VMs which is being sitting. Because remember, Pratik is being paying $1 only to host one particular VMs. So it doesn't claim that you're claiming one full blade servers. So you might be a part of that very blade servers, and there could be another users who might be using it. So what are the backend things which is making the segmentations to be occurred? So remember, guys, to really segment all this traffic from a basic networking, what we should be doing? Any idea? So guys who might have not done the public cloud experience, but at least from the basic levels, if you try to talk about if I have to segment this traffic, how we would be doing that kind of segmentations.
Yeah, we
Answers are
have to
coming.
do. Yeah,
Yeah,
VLANs. We have to do VLANs.
exactly. We do have VLANs, but we do have some limitations with VLANs, right? We do have a number up to 4094. And even like 4094 numbers, some of the numbers have been already being reserved. Even some of the switches will be not able to capable to run that number of VLANs also. So it's not only 4,000 customers have been coming up in your infrastructures. It's being a lot of number of customers who's going to come to your environment. So obviously, in that cases, we have to go with the complexities of VRFs. So VRF, again, it will be having a limitations. Obviously, if we'll take a look on any of the product lines, how many number of VRFs we can create, at least there would be some sort of limitations. And this was the major pain point which we were facing, not only in the public cloud, even in the private clouds also. So if I'm providing a cloud services to different customers, how we are going to segment that traffics, though we had a VLAN concepts, but it was still not enough for us. Because one VLAN might be we are going to give to one customer, but again, that customer will again create multiple numbers of again and again some sort of VLANs. Because it's not only single applications, it's not only the work of your a single applications. There are a lot of number of things, like there could be a cluster of web VMs, there would be cluster of DV VMs, and there would be cluster of app VMs. So accordingly, you have to provide that infras. Plus, you have to make it sure that there's no any kind of sharing of the subnets. But you can't really tell to a particular customer that, bro, that this is the subnet that I'm just giving to you. You have to use only this subnet. So that flexibilities you were not providing earlier, but now with the introductions of concepts of VXlan, we will try to give that kind of achievements. Okay, but ultimately the VXLAN that we tried to create between each other, that is still being called as what kind of technology? That is still overlay technologies. Now, why we tell it as an overlay? Remember, guys, if a customer is being there today, think about that. There are 3 blades. Okay. Now, when we have a 3 blades, a customer come up and he creates his own VMs. Maybe I'm going to draw the VM of customer number 1 as red one. So he has created first VM, second day he created another VM, and third day he might have created another VMs. So you will be not able to claim a particular blades. It can go to any particular locations, right? It depends upon the availability. Now, on the basis of the availability, all these particular VMs will get attached to the respective blades. But now if I have to connect each other with these devices, because always you have to always think about some of the another customers who would be also running the things. Like there could be a green color customer. I should be writing 2. So you have to not make the traffics to go from one customer to the another customer. Think about there's a full fabric network that is already being present on the top. Now, when we tell that it is a fabric, it could be even what? A LAN network, or even it could be a SAN network. So when we talk about in a LAN network, when we talk about from a data plane point of view, we need to have a proper segmentations that whenever we create a segmentation for this customer, only these very VMs will get connected to each other. When we do have another customer, we would be having a different overlay that would be created. And accordingly, only they will be allowed outside of this public environment. So this is being also one of the very basic requirement from the overlay place that you have to really achieve in any such kind of data centers. So I'm just talking about one cluster at this moment. There could be multiple number of cluster per customer, which we call it as a per tenant. So whenever we tell that it's a tenant, think about just like a customer, what I'm talking about. Okay, so the number what we were trying to get from VLAN, that was still not enough. So we had to go with the evolving technologies of VXLAN, and it had to do that stuff for us. Guys, just give me 1 minute, okay? I'm sorry, guys, I'm back. Yeah, Kashinath, I'll send you the recording, no issues. But meanwhile, you can even start the recording. Let me just allow you to record. Yeah, I think you can start the recording. All right, guys. So this was one of the example what I can tell you about the overlay at this moment. So when I talk about the fabric at the side, you would see that it's not only the involvement of only one switch or router. There could be multiple set of routers that would be present on the top. But obviously, nowadays we do go with the best set of designs. And the design that we do follow is the leaf and spine, or sometimes we call it as a cloth fabric. Now, leaf and spine kind of infrastructures is if you have been coming up from the routing section background, we might have heard about mostly like a core layer switches, then we had a distribution layer switches, and then we had an access layer switches. But when we go with three-tier architecture, there's a lot of number of complexities that we do see as compared to the things which we try to achieve with the help of spine and leaf infrastructures. Now, usually in the spine and leaves devices, what you do find out that we would be having a core kind of switches, a huge number of switches on the spine levels, and you would be having a distributed infrastructures of your leaf switches like leaf 1, leaf 2, and leaf number 3. Now, from the basic connectivity wise, you would find out this connections of spine will go to each and every leaves, even from the another spine. So the idea is that you should have all the leaves connected to all the spines, but there would be no any kind of spine to spine connections that we try to achieve, because we don't try to send the traffic from one spine to another spine ever. Because all the workloads of your blade servers, because this could be blade servers, it could be even routers, or even it could be a switches. So this could be switches. So all these connectivities, we try to get connected to our leaves with the redundancies, and these routers would be also getting connected to our leaf levels. We never ever connect our spine to any other devices until unless we don't have a special kind of design that could be on a multi-site kind of environment. So when we go with this kind of infra, which is one of the tested way of designing the telephony networks, when you talk about the class kind of fabric, it has been not originated from the IP networking. It has actually evolved from the telephony networking. And they claim that whenever you go with class fabric, you can have more switching path as compared to the path that you do get in the core distribution and access layer. And ultimately, this is the thing that we want to achieve. We want to make any of the VM traffic or any bare metal traffics to go from each other in a redundant fashion. So when we try to send any traffic from particular VMs in this very way, it would be a full involvement of your leaf, which can load share the traffics, and this spine will send the traffics to our bare metal. And this whole traffic flow, if one of the spines still goes down, you would see there would be vaguely any kind of differences in the traffic flows. So obviously there would be a bandwidth decrement that you would see, but ultimately the traffic is going to flow with the full redundancies. So this is one of the way of telling that how the leaf and spine is going to get connected. So it could be a routing network or it could be a switching network, but mostly we try to achieve it through the routing. We'll see what in the later courses, what is the meaning, why we would be going with routing and why we shouldn't be going with the switching world. But at this moment, if I would have been using a switching network between leaf and spine, what could be the problem that we can face? Anyone who can actually tell? I'm sorry, I don't have any kind of gifts that I can provide you, but yeah, if we can make the classes more interactive, it would be really nice.
Could you repeat the question?
Yeah, the question was that if I had got leaf and spine, okay, so is it good to have routing on the top, or is it going to good to have a switching on the top?
I think if we put in switching, then how do we segregate the VRF and customers for different setup? Because this will be shared leaves, right? One leaf will be shared by many customers.
No, actually, that's the worst thing. Like, I wanted to know about that stuff only. So is it like leaf we are going to share to a particular customer? No. This leaf will be only present in the infra. A customer would never ever have a hands-on to their respective leaves. Customers, their basic requirement is to do what? To host their application, provide the security, create the VLANs or any kind of segment, whatever they want to create it, right? But do we see that AWS provide a switch to us or a blade to us? They never ever give us that things. So it's not like that we are going to provide leaves to our particular customers. Never we do that things. We try to give our infrastructures over it. You are going to build over a VLANs, but we will be telling that we are going to create VXlan over there. So in that context, when we talk about whenever there's a leaf communication to the spine, what kind of communication it should be? Is it good to have switching, or is it going to have good to have routing? I'm just making a questions over here, not purely from a data center point of view, but yeah, if I see two devices being connected in this fashion, is it good to have switching or is it good to have routing? I just want to understand. I want to just get an answer from there. Okay, there's a question, there's an answer switching. Now, can you tell me what would be the best thing about switching?
We can switch in wire speed without the lookup delay. In routing, you have to do two lookups, in the rib and the fib.
Yeah, that's one of the good
latency point of view.
observation. Exactly. Yeah, that could be one of the things that you can really come up with an answer. Yeah, maybe there could be a latency issue or many kind of other stuff, because when we talk about routing, a router will get a traffic, okay? It will be encapsulated with many another encapsulations. It has to decapsulate, right? And there could be a problem of latencies. But remember, when we talk about routers latencies while doing encapsulation and decapsulations, it totally depends upon the hardware and what is the chipset that you're trying to use it. So there are some scenarios when the customers will be claiming that whenever we use Juniper devices, it is much faster as compared to Cisco's devices. So there's always a lot of number of cases that used to come up. And according to it, only the customer will tell that, no, Maybe in the next cycles, we would go only with Juniper devices. But guys, remember, we are now in the era where we will be not telling to this vendor that who is much better from the hardware set at one point. What I'm trying to achieve, what I'm trying to tell you as an answer, that nowadays every company is capable to create a hardware which will not see these kind of problems ever. I'm still telling that switching would be much faster as compared to the routing, and we might be seeing this kind of problem maybe 5 years or 6 years before. But today, whatever the hardware that is being developed, they are being aware about these kind of issues, and it can still do the routing, okay, with a wire speed what we usually get achieved whenever we used to do switching. So we should not tell nowadays that there could be a latency issues or all those things. If you see from the global answer, when you talk about switching, one of the major issues that we would find out is the looping. For the loop preventions, we always go with what protocol? Spanning tree. And whenever we go with spanning tree, it will just show us how many paths? Only one single path. So in this whole scenario, when you talk about when we do have spine connections to the leaves, think about this is the root. Maybe this is a standby route, but still it is a standby route. Okay, maybe you might have done route for even VLANs. You have done route for this odd VLANs. Might be you're doing the load sharings, right? But still you do have how many paths that is being used for the traffic flows. For even VLANs, you will be using spine 1. For odd VLANs, you will be using spine 2. But you are still not using both the paths. You are just making only one flow of traffics, right? We are never ever doing a stuff called ECMP, that is called equal cost multipathing. And this equal cost multipathing would be always a necessities that we do require over here. Because if let it be there's a huge traffic on the even VLANs, all this traffic is being going and this has been congested. But still, if you have to send another even VLAN traffic, you have to use that path only. You can't really switch over to the another path. But when it comes to the routing at this moment, whatever the number of spine that you do connect, maybe you have got 4 ways. So you need to have 4 spine switches. So you would try to achieve 4 equal cost multipathing. And that equal cost multipathing you can only achieve with the help of routing, not with the switching. So in this cases, routing will be much better. But again, the complexities that you can come up through with the routing, that you have to do a lot of number of configuration, right? When it comes to routing, you need to have an expert on OSPF or maybe BGPs, right? And whenever we talk about 5, 6 years or 10 years before that, do you know BGP? I know like most of the people will be telling that, okay, it's pretty tough technologies, right? What are the different loop preventions? And there are a lot of number of questions that is been coming up on BGP side. So we need to have expert levels on the routing side, right? But over here only the great advantage of switching that you would get. Switches, does it require a proper configurations? No, it's a single line of config. Just put a cables, connect them, spanning tree protocol is going to run. You don't have to do anything. That's an automatic process. But routing, it has to be configured properly. So in that context, there could be a lot of number of tug of war between routing and switching, which is being much better. But again, what we want to achieve, that we have to achieve maybe with the help of automations nowadays. Like today, the routing which we have to configure, we'll be doing some sort of automations. Because in this case, there's a simple set of configs that we might be writing, but it has to be repetitive. So when I'm going to write on a repetitive set of configs, I can automate that things. Okay, so I just wanted to give you some overview, guys, how these things is going to work. So at least if you do have any questions, let me know. But I know people would be claiming all the time, routing is much better, okay? Or switching is much better, it depends. There's the answer from Sumit, routing for better control and load balancing, exactly. But complexity is that it has to be configured properly. Okay, so I think I've been talking a lot. So that was the software overlays, guys. Now the overlays that we tried to create, it has to be overlays. Now that overlays might be we can achieve with the help of NVGRE, or maybe it could be VXlan. Now at this moment, Cisco ACI does support both of the technology. NVGRE, this is one of the very common technologies from Hyper-V or a Windows level. And VXLAN, it is being accepted by most of the Windows at this moment. So when you go with KVM, OpenStack, VMware, they all do support VXLAN. So now the industries are being moving not at this level, only from a switching level. Even when you do have a VMware blades, okay, maybe this is a VMware blade. Maybe you have installed the ESXi. See, ESXi is the operating system which you install on the blades or on the rack mount servers, and that virtualization layers would be created on it. So the idea is that even the overlays can be a software. So you can actually create a particular VM kernel, similarly like how you create a SVIs, and you can create an overlay networking from one to the other devices. In this case, the role of these leaf switches and spine switches is to just provide an fabric, like just to make them to connect to each other. So these are actually an IP-based communication that happens from one VM kernel to the another VM kernel. But at the back end, there would be a VXLAN encapsulations that will be provided by the VMware operating system itself. So this could be one of the another cases that you can think about, guys. A lot of number of things that's being evolved, but we'll be seeing from our scope what are the achievement that we would be doing from ACI world. So in this whole topic, the whole idea is that when you want to achieve the overlay networking, it is good to have the clause infrastructures. So whenever you go with clause infrastructures, you can have more switching path as compared to the core distribution or the access layer kind of designs. All right, so let's move to the ACI's overview and terminologies. What are the different things that you do get? Now, whenever we talk about ACI, okay, in most of the PowerPoint, you would be seeing this particular term like stateless computing of UCS. So some of the folks, they might be knowing what is UCS, and they might have experienced it, what is all about this stuff. I must be telling this is one of the very revolutionary product from Cisco on the server blade side, like how to manage more number of servers and blades, and how you can make some sort of virtualizations to come into the effects. So people who might be not knowing about UCS, this is a way how you try to define how the server would be connected, how the server will be built, and what would be the capacity of those particular blades. Like today, if I have many number of blades that's been hanging in our data centers, right? Now, if a customer claim that today I need around 4 number of NIC cards. Now might be this number of NIC card they will be using for different applications. Maybe they would be doing a NIC teaming, and whatever the VMs or the application they are going to run, they want to send it traffic in this very way. But there could be some like necessities for the another blades where they would be needing maybe 2 sets of HB adapters. So maybe there would be 4 vSAN that you want to get it connected. But always a question would be arise that if I have to make these kind of customized settings, obviously I need to send a field engineer to the data centers, and I have to give him the capabilities to provide that number of NIC and HB. He has to install to that hardware and do that some set of configurations. If I have to do any kind of settings to them, maybe I have not got the proper connectivities. He need to have connections of KVMs, and then on the blades, he has to connect his laptop and do the set of configs. So it has been a very, very tough task for most of these server guys visiting data center day to day and doing these kind of activities. Usually, these things can be better now being achieved with the help of UCS stateless computing. Idea is that if I have to do any kind of things on storage side, like today, if I have to create and storage in the servers, maybe it could be a learn set of settings, defining a persistence binding, whatever the data that I have set. Maybe if I have to connect to a particular set of vSANs, or maybe it could be a server related configurations, or even it could be a network related configurations. So whenever we tell that it's a stateless computing, the idea is that we would be having the blades. We will discover all these blades with the help of devices like Cisco FIs, that is being called as fabric interconnects. And we would be telling to the UCS fabric interconnect with the help of um, service profile. So service profile would be having all sort of information about the server's configurations, like how server would be running, how many number of NIC card you would be having. Might be we require 2 NIC card, 4 HBA cards. It has to be getting connected to respective VLANs. It has to have a particular BIOS settings. So all those things you would write down that things as a service profile, which is just an XML file. But again, you have to not do the coding of XML. That GUI process you're going to get in FIs itself. So as number of servers, what you do need, that number of service profile, that customized configurations you will create as a part of service profiles. So today, if I need these kind of setups, I will just push that particular config to a server itself, and the servers will be going to create as per the demand what we have requested in the service profile itself. So you have to not send any kind of field engineers to the data centers and make that kind of customized configs. It's all the logics and all the magic play of service profile, which is going to do all this kind of tasks. So it's being like how we need a server that way that we are going to create with the help of service profiles. Okay. Now, the same thing is being also being seen nowadays from a networking itself. Like today, if I had to create a service, we now create Cisco's guys are more now exposed how to use UCS, how to create this kind of service profile. And the same ideology, they thought that why don't we put that things in their networking, basically in the data centers. Because ultimately, when you talk about in the data centers, you do have a particular set of config that you have to always do. And to really achieve that set of configuration, there's a lot of number of teams, there are a lot of number of human efforts that is being required to make that kind of connectivity sets. So this is one of the very best example what you do see at this moment. Like if I see any application, and even when you talk to any application guy, they have their own world of thinking. I must be telling, because I've been talking more like most of the developer guys, and whenever we tell that I have to put a application, they will always think that this application has to talk to web servers, this has to talk to database, and then it has to go to internet. They have that kind of visibilities. But as we are a networking guy, we know that what are the problem that and what are the tasks that we have to do so that to make that kind of connections, right? Now, if you see this particular model, this is a 3-tier architecture model of an application, which is a very common thing that you do see most of the time. Like there would be a web applications, there would be app application, and then there would be cluster of databases. So whenever a user, which could be me, and if I have got maybe networkershome.com website, today I'm being hosting it to a particular data centers. So you are going to come as an outside user. Okay. So whenever we are coming from an outside user, obviously we need to provide some sort of security, right, in our infrastructures. So maybe we are going to provide a stateless or stateful kind of firewalls. Again, it totally depends upon you. So as an architect, you have to give ideologies, you have to give architectures, how this traffic is going to hit from service provider to your routers or to your firewalls. And then you will try to send that traffics to the respective applications or the web service. But it's not only the firewall that is going to only being used over here. It could be a load balancers also. Because if you are using maybe a Windows mobile phone, or maybe another user is being using Apple mobile phone, they might be getting some different servers. Okay, but it would be a single set of IP which will be load balanced to a cluster of many number of web VMs or web servers that's been running at the backend. But before making that traffic again, it has to come as a QoS as a rule, filter as a rule, which is again a security rules that we do provide. And then we would be having some sort of services like load balancers, or maybe it could be a VAST services. And then we try to send that traffic to the respective cluster applications. Okay, now when this traffic comes to your data centers, obviously you're going to find out one of the web servers to you. Now, this web servers, you have to tell that maybe you want to make them to communicate to each other, which we would be doing mostly, right? But whenever an web application, it has to always query the things to which guy? The app applications. Now, there could be a lot of situations where you would see that one of the hacker comes to the web servers and he can pull out all the databases. So you need to have a proper security to move the traffic from one cluster of traffics to the another cluster of traffics. Same way, when the app will provide that data, it has to always query to the database clusters, which could be of Oracle, could be of MongoDBs. It depends as per your architectural designs. But again, whenever you try to send the traffic, it has to involve a different services. You have to define a filters between them. And then you would see that your applications will provide you the web page of any particular website, or maybe any specific application which would be running internally to your networks or maybe external to your networks. So this is the flow of traffic which will be always being present in DC's environment. And when you come up from an infrastructure point of view, we know what is a pain to make these kind of connectivities, right? And there is a lot of number of involvement of a lot of number of components to provide agilities, redundancies, and provide secure traffics. So that is the pain point which we will be trying to solve it from the ACI's world. But again, as I was claiming all the time, like as same like as of UCS, we will try to have stateless computing. Similarly, we would be having a stateless provisioning of this application sets. So as like an application developer guy, now we have to work as in a networking. Like today, if I have to create a web, we'll create quickly a web EPGs. So today, if I'm telling that this is a cluster, we would be calling this is a group of many devices which will be having the same properties. So whatever the EPGs that we create at this moment, maybe this is a web EPGs. So whoever is the web application VMs are being present, they will be part of this particular groups. Now, it doesn't matter that they do have different set of IP. You can have different IP, you can have different VLANs, doesn't matter at this moment. So in this hardware design, when you try to see, maybe there's a particular blade which is being running web. Similarly, there's another virtualizations where you do have a particular VM for your web. Similarly, the same one is being running an app for your applications, okay? But in these conditions, which are the one which has the common property? This is the one which will have a common property. This will be having a common property. And this will be having a same EPGs. So you can think about EPGs as just like a family, what you do get, okay? A same set of families. And accordingly, only we try to provide the policies to them. Because today, if I have to apply a policies telling that whoever which is being coming up from port number 80 or 443, they are being only allowed. I don't allow traffic which is being coming from a port number 123. If I have to apply this kind of securities, what are the things that we have to do? Like if I have to apply the securities on the server levels or on the VM levels, we have to do a lot of number of tasks, right? We have to go to the respective servers, apply that kind of securities. But if I would be applying that kind of policies on a EPGs level, telling to the family, whoever are web, apply that policies. Everyone, maybe that is a bare metal, virtualized servers, they are going to apply that kind of policies to them. So that's the policy model which we are trying to talk about, applying it more easily, okay? But we need to know the fundamentals, some of the terminologies of ACIs at this backends. So when we call it out as a filter or service, we are trying to claim a specific process in ACI, right? And what are the policies is being created? That would be created with the help of APIC. And it will decide that what kind of policies will go on what switches. Okay, like this time web and web is only connected on these switches. So the policy should be written only where? Only on these switches. It shouldn't be written on the other set of switches. Okay, so that controlling functions and functionalities we are going to just provide to the APIC devices only. He would actually take monitoring services like what are the switches which is being present, where to apply that policies, how the VMs are being moving. Accordingly, we are going to move the policies also with them. So as you move your devices, the policy will also move accordingly. But again, remember guys, it's not only for one customer, we are creating for multiple customers, these kind of models on the same infrastructures. Even you can use in your enterprise network as claiming that maybe you do have to create a test environment, DB, or many other things. But did you understand what is the scope, what we are trying to create at this moment? I would open the time for your query. If you do have any query, we can take down the questions. Otherwise, we'll take a small break. We'll come back and then we will continue with the topic. But anyone does have any kind of questions?
Hey, Abhishek, when we apply this endpoint group policy and we say that the web can only access application and it will be only accessing certain ports or some, so in the background all the below level stuff will be taken care of, is it?
Yeah, exactly. So that's not the thing that you have to go out as end user and have to verify. That will be automatically done by the APIC levels only. And this is one of the, again, a pain point, mostly people who had been working in the infrastructure. Like if I have to apply a security policies, it has to go to the respective web devices only. And even the pain point that we would discuss in the later sections also, if we change the VLANs, there are a lot of number of changes that we have to do, right? But that are not the thing which we would see as tied in ACI. We don't apply the policies on a VLAN or a IP subnet basis. We apply the policies as per the family of EPGs. So that's the, but the question I think was that whether the policies will be applied, do we have to verify that things? I would be telling 99% we should be not going to see that things that will be applied automatically.
Okay.
All right, so if anyone has the another set of questions, let me know. I'll just wait for another 1 minute and then we'll take a quick break and we'll come back and then we will continue with the topic.
Abhishek, this is Nazir.
Yeah, Nazir, tell me.
Yeah, just quick check. Like actually, I was a little bit late, and this one was first session for me. I had enrolled for data center track. This one was a CCNA track, data center or SDN.
I'm sorry, Nazir. I hope the question was that is it data center full boot camp you're talking about? It is, or is it for the just for SDN? Is it that the question?
Yes, yes.
At this moment, we are just taking first of all SDN. Okay. After completing the SDN, then we would move to the different topics.
Okay. So this one is a CCNA data center. Is that correct?
No, it's basically for CCI.
CCIE.
Yeah, we are actually making it sure that you do get the fundamentals of NA and NP, but the bootcamp, what we are trying to claim, that even though you don't have proper knowledge, I'm trying to get you to understand on CCNA level, CCNP, as well as on CCI levels. So I'm going with from a proper basics, then we will go to the higher levels also.
So this one is a CCIE data center track today's session. Is that correct? And
Yeah.
basic level. just we are just covering basic topics just to make a start. Okay.
Exactly.
Okay.
Exactly.
Thanks, Abhishek. Thanks.
Okay, guys. So if you do have any questions, put that things on chat box. We'll take around 10 minutes of break. Let's meet at 7:15. Okay, we'll assemble back, grab a cup of coffee. Okay, talk to your family, and then we'll meet up at 7:15. Hey guys, welcome back for the sessions once again. I hope everyone is there. Yeah. All right, so let me first of all go back again and talk about what we were trying to achieve. So ultimately, we talked about how we are going to create the networking profiles now. It's not like similarly like how we were creating the networks piece by pieces, creating the VLANs, applying the subnets, and applying the securities and routings to them. We are trying to put up full packages now as a network profiles whenever we have to apply any kind of applications. So now the idea is that if I have to really create all this kind of setups where we would be having outside networks that's going to come inside to the data centers, applying a related securities on it, okay? Then applying that things as like a web EPGs traffic, then similarly how a web will talk to an app and an app will talk to a particular DBs. Okay, so when we go with this whole flow, we can right now write this as a full package called as a application profile, or maybe you can write down as a networking profiles. So whatever the thing that you have written over here, this will be written in a coding formats. Maybe it could be written in the XML formats, or maybe it can be even written in the JSON formats. So ultimately, it's a configuration backups what we nowadays take. It's not a very similar configs that we back up in a basic routers. Nowadays, we back up all those things from an XML or maybe from an API's point of view. So that's the one thing that's being shown out in this particular PowerPoint, where it is basically explaining the full package as one set of networking profiles, which would have all sort of things like what are the different application tiers. So it could be web tier, app tier, DB tier, how the connectivity policies would be created. Like in this case, I'm not making web to talk to DBs directly. It has to go with a proper flow. Similarly, how it is going to be going through an L4 to L7 services, because at this moment, at the middle, it's a full involvement of a particular security things that's been coming up, and accordingly, only the traffic is going with the proper policies. So this is just an abstractions of your infrastructures which is being created, and now the things is becoming pretty easy now. What we try to achieve in the infrastructure building. So the application policy model is all about this stuff only, like what I want to achieve, so that we are going to build as per our architectural view. Usually this is the architectural view that we created at this moment. And when we apply that things, ultimately it is going to be applied on our leaf and to the spine switches. So this is a policy instantiations that we are trying to do, that each device will have a dynamic instance that require the changes based on the policies. And this is the point that I was trying to talk about. Like when we had a web VMs, which was connected to only switch number 1, but there was some VMs which were part of DB or maybe of app. Accordingly, only the policies would be distributed. So that distributions will be taken care by the APIC appliances. Obviously, this appliances will be not a virtualized one. It would be hardware boxes that you have to buy from Cisco. So I'll talk about it, how these very hardwares looks like, but I'm just trying to give you the fundamental understanding what we are trying to achieve. Now, the another thing that you would also come across when you see at the bottom most, the IP address are full portable anywhere within the fabric. Now, this is one of the very pain point that most of the infrastructure guys comes all across. Whenever let it be, if I have to define IPs to a particular infrastructures, we have to obviously take a look on our spreadsheets, find out that what would be the IP that we can define in this particular VLANs, and accordingly only we try to provide that IP, right? That's the way that we might be following. But this time, it's actually, you can have any IPs at anywhere at the locations. It doesn't matter until unless it doesn't come up with the duplications in the same EPGs. So the idea is that you can have any subnet, any IP, that doesn't matter. So the idea is that if you do have your web applications, usually in the real infrastructures, how we do create it, we try to define a specific VLANs to them, like maybe VLAN number 10 is only for the web tiers. And accordingly, we try to define the subnets, maybe 10.1.1.0/24 is only and only reserved for VLAN 10. So this is the coupling functionalities that we always define, that a VLAN will be always mapped to a particular subnets. And accordingly, only we try to define the IP addressing. Same way, the app will be having again another set of VLAN, maybe VLAN number 20, and we would define 20.1.0/24 subnets to them. So this is the backend process that we always follow, and we try to define the configs to them. And obviously, when it comes to the security rules that has to come up into the place from web to app, we always tell that whatever the traffic that is going from this subnet to the subnet, we would be applying the security policies. But now the things is being quite changed. You can have a mix of the subnets anywhere at any of the locations at this moment. It doesn't matter in the ACI world. You can have a mix of 10.0.10.1.1.0 for the web, as well as you can have 20 and 10 at the same time. The things that is being applied over here, that's being done on the EPGs basis, that's being not applied on the subnet or in the VLAN basis. So that's the one thing we'll try to see in the proper labs, how it is being achieved. So obviously, when we try to go in that very way, we are trying to decouple that functionalities of our securities as well as of forwarding. Earlier, like if I had to make any traffics to flow from VLAN number 10 to 20, or have to apply securities, we apply on the subnet basis. But this time we are applying that things on our EPGs level basis. Like whatever the guys who are part of web, whatever the traffic that is going to app, they would be having a proper policies what an end user would be creating. So that's the one thing which is going to always save us from the scenarios where we have to make a proper changes. Because remember, when in our infrastructures, if I have to change a VLAN or a subnet, we have to do a hell lot of number of changes in our infrastructures. So we can sometimes think about, we can never ever think about to make any kind of major changes, what is being done in these kind of configuration changes policies. So thing is that devices are autonomously update the state of the network based on the configured policy requirements. So obviously these devices will demand that I do have now web devices connected. So accordingly, the policies will be distributed to the switches at this level. So this is being called as an application policy model. And on that basis only, the traffic is going to behave and the customers would be running their workloads behind the ACI's fabric. So ACI fabric is all about the combinations of your leaf and spine switches connected through your APIC devices. And the downside, the workload is all depend upon what kind of workload locations or the traffics that you're sending, which could be a VM based traffic, could be a bare metal device traffic, could be a layer 2 out traffics, or could be a layer 3 traffics. So it could be any kind of traffics, and it all depends upon your topological design, how you're going to architect that kind of traffic flows. Right. So on that basis, this is the one of the common figures that you would always see in the system, how these things are being getting connected. So as I was keep on telling, the fabric, which we call it out as a single combo switches, where the spine and leaf will be having a combined effect of making the traffics to flow. So in this cases, the downside, the workloads which you do find out could be a external layer 2 and layer 3, which could be a connectivities to your service providers, all right? Or maybe it could be a legacy environment of your layer 2 environment. So those environments are going to get connected to your leaf devices, and accordingly, you are going to transfer that traffic to the respective customer tenant interfaces or the tenant VMs that is being running as the blade servers, or maybe the bare metal servers, which is being there. Now, even when you do have some devices like your ASA firewalls, like in this cases, this is one of the firewall which you have got it connected. If it could be even the Palo Alto could be Citrix firewall. And if you have to have traffics to flow from web to app, it has to go through this very firewall. You can even write on that kind of policies to them. So just to give you an overview, if I do have this kind of system, okay, and I do have a policies that I have to write down accordingly. Okay, so when we talk about a design, let me just take a example from a design basis. Okay, so this is one of the physical figure that I've got, but let it be the architect has created a logical diagrams where the users will be sitting outside, which is going to come up from the internet. Okay, so these are the internet based traffic that is going to hit to our data centers, and that is going to hit first to our web applications. But before web applications, we need to have a ASA firewall. Okay, I hope this is the way that we try to build the infrastructures most of the time. Now this ASA firewall will be getting connected maybe to the load balancers, right? And this load balancer would be getting connected to our respective VLANs. So now this VLANs will be a part of our web applications. So when we do have a web applications right now sitting over here, they will be a part of our particular groups. So this could be called as like a EPGs at this moment. Now from the web, we would be having a similar infra, like maybe we would be having a firewall again. Maybe that could be an ASA firewall. And again, we would be talking to our app traffics. Okay. Now from app, again, we would be sending that traffics to a firewall, ASA firewall, and then we would be sending that traffics to our database. So this is usually the flow that we try to build. We try to define the respective VLANs, defining the subnets, but the ideologies are not going to be pretty different. The ideology is going to be pretty same again, but all these things we are trying to achieve through the ACI policy models. So now if I try to see the traffics to flow from an external world, so this is an internet based traffic which has been coming up over here. Now who is external present over here? This is a service provider router which you have to connect to one of the leaf devices. So from here only the internet traffic is going to hit to the routers. Okay, and in these conditions you have to have some models like L3 out so that the outer subnet traffic can hit into your data centers. So from an ACI logics, you have to basically attach these pieces by pieces. So whenever we talk about L3 out, it is basically a flow of one subnet or the outside L3 networks is coming inside of the another networks. Okay, where we are trying to involve any kind of routing protocols. So in a very layman language, when we have an involvement of outside routing protocol, then we would be going with L3 out. But remember, this internet-based traffics, we are trying to define as one set of EPGs. And according to only, we are going to write down the policies like maybe port number 80 and 443 only we want to apply to it. So this policy is where we are going to write down that we are going to write down on our firewall. So the thing is that from internal point of view, this traffic will go first of all to ASA firewall, and then it will come outside after processing the firewall policies what we have written over here. So whatever the policies that we have written on the ASA firewall as like our filtering logics, which we can achieve with the help of L4 and L7 kind of integrations. So in this cases, you have not tell to the switches that you have to send that traffic to that firewall. That would be done automatically by the L4 and L7 kind of integrations. They would be defined in this very way that whenever there's an internet-based traffic, it has to first of all go with the physical firewall. Similar way, if let it be you do have your load balancer appliances that you have also connected, maybe F5. Now, the next thing that is being coming up is what? Load balancer. So when this flow came outside, it has to go again through the F5 load balancers. Okay. And then accordingly, the load balancing terminologies will be applied and the web traffic will be going to head to the respective VMs. So maybe that web VMs might be sitting over here or might be sitting over here, doesn't matter. Now this traffic will go accordingly and it will head to the respective web VMs. Okay, and that very web VMs will process that very traffics, and again it would might go with ASA firewall if it is your wish from the architectural levels. So again this traffic will go from your ASA firewall, and this traffic will go to your database or application, and same kind of way the things that you have as your program, the traffic is going to go again and again. So the thing that we are trying to achieve out over here with a single firewall, with a single load balancers, you're giving all the customer that specific services, maybe as like firewall as a service, or maybe load balancer as a service. And entirely this whole infrastructures you are providing as a infrastructure as a service or application as a services. So you can provide this kind of services in many, many ways. But what the end users would be doing, mostly he has to create these kind of policies one by one. So when it comes to web, how it is getting connected to the bare metals, you need to understand how we would be getting connected to the bare metal devices. Maybe your app VMs are being present as VMs, which is being present in a specific one cloud, or maybe it's being present in the VMware cloud or a Hyper-V cloud. You need to make that kind of integrations into it. So in this whole thing, you have to know how we are trying to do the service chaining, how we are trying to do the VMM integrations. Guys, just give me 2 minutes, okay? Hey guys, I'm back. I'm sorry, actually, I was searching for my charger because I'm just short up with my battery. Let's see, I didn't find out. I think I'm not able to get it. I'll have to really search it. I think it will still hang on for half an hour. All right, so what I was trying to explain over here, the flow of the traffics, the flow of the different services, which is going to be involved in the ACI side. So according to it only, we have to achieve the task. But obviously, the guys who have been coming from the infrastructure building side, you might be seeing how easily we are going to achieve it. And whatever the different things that we wanted to see as a flow of the traffics is being done, not with one proper way, like creating an ASA, putting a particular interfaces over here, making that another ASA, putting that another interfaces on the web, Lex, and similarly on the other apps. The same firewall you can use for multiple kind of services. So that's the one of the thing which we would achieve, not only with the ASA firewall, it could be even Checkpoint or it could be a Palo Alto, because ACI will provide you the third party integrations with the another set of load balancers also. So if you want to really understand about it, you would see there would be L4, L7 services from ACI, the third party interoperability. You are going to see a lot of number of vendors who would be there. So this is a list of solution overview. Not only with the firewall, there would be many another things that you're going to get. So you do have ASA, you do have Checkpoint, you have Palo Alto, Fortinet, integration modes with the ADC vendor, and many another things. So you can find out this particular list, and for what very versions you can find out that kind of packages. All right, so that's being one of the key features, guys, from the technology and from the architectural view. But on this whole part, you would see that the APIC would be put as a cluster because I want to still form the redundancies from the policies written, and we need to apply the policies onto it. So APIC would be the devices where we would try to log in, and we'll try to apply all the set of config as one side. Now, whatever the switches that you see at this moment, we will see it as a single logical system. It will be not like all different switches. That's the view logic that you have to think about from your end. But obviously, we know from infrastructure levels, all this would be a switches that is going to be implemented. So this is one of the common set of design that you do see. Over here, you can apply the different set of solutions, which could involve the integrations of VMware, integrations of your Checkpoint, integration of Kubernetes, Docker solutions, and even the OpenShift. So whatever the infrastructures which you want to achieve, it can be done by this particular method nowadays. So any questions, guys, up to this moment? Just give me a moment, guys. I think I got my charger so I can apply. Otherwise, I would be dead. Okay, just give me a moment. 1 minute. All right, guys. Here's a question which we are getting from a chat. Same physical firewall for all three firewalls entering web app DB servers. Yes, you can do that things, but if it is your wish, okay, again, totally depends upon you, whether you want to go in that very sense or not. But usually if I have to get that opportunity, I would be doing with not only with one firewall, I'll try to cluster that very firewalls. So basically in the ASA, I'm going to put a context firewalling kind of concepts there. But there's a proper design that you can follow. Like if you would be doing ASA firewall design with ACI, there's proper design models that you can check it out. How are you going to apply that models? This is one single. This is dual homed. There's only one I have seen. There would be one more. What you would be finding, yeah, this is the failover one. So it's being clustered over here. So you would find out that all the workloads will be going through the firewalling mechanisms, and that's going to be run by these single firewalls. But still, I'm going to apply the failovers to them. But this is one of the corner cases that you can get it out. So it's a nice design that you can follow. Okay, so even it does have the new set of firewalls which can be supported by it. So if you might be knowing what is the new firewall from ASA from Cisco? Anyone who's coming from the security background?
Next gen firewalls?
Yeah, it's the next gen firewall that's from Cisco. It's I'm sorry, I didn't got the name. Yeah, Firepower, correct. That's the Firepower. So this is the next generation firewall, even it is being compatible with the Cisco ACI. So it's commonly being implemented a lot, but again, it's customers' wish. If they are more used to Palo Alto, they can still do that things. You do have a proper packages, apply that packages, whatever the config that you want to write on, need not to go to Palo Alto, you can apply that things from an ACI things only. Because nowadays, everything is being running on an API. It's not ACI, remember, it's the API logics. API is again like a programming levels, or it's a communication channels. That's the new way of doing the configurations on any set of devices. So that's the channel that we can really implement in the ACI worlds. All right, so the next topic which we would see would be the application language barriers. Obviously, guys, there will be a lot of number of theory that we have to understand, because it's being a very new things and people get a lot of number of confusion. I would recommend, if you do have a lot of questions, put that questions on the chats. At least people would get the understanding. And I know people would be coming up from the physical background. Some of the guys who would be coming purely from a routing, maybe from security background. But think about from a DC's environment, what we have to really achieve. And accordingly, only we are trying to take down that very theory, and then we will see the practical levels, how we would be getting connected to them. Okay, so questions are always welcomed. Now, the next thing is the application languages, what we have been talking about. This is one of the example which we already talked about, that whenever we need to write down any kind of network related policies, which would be mostly like permit deny, making a marking of the traffic, maybe we have to apply the logging functionalities. We apply that things on mostly on a subnet, or maybe coupled with the VLANs. Similarly, the SLAs and even the L4 and L7 services. So there could be a lot of number of things that's being constructed from a networking levels and apply that things on a VLAN or maybe from a subnet levels. But now when you talk about from a developer's point of view, they see each and everything from an applications, like what is web, what is DB, what is uh, um, applications clusters, and accordingly only we try to they try to develop the things. But whenever we see the things from an infrastructure levels, we always see the language of VLANs, subnets, protocols, and what ports we have to open. So we have to always involve the application guys and ask them that what is the application, what is the port number we have to open. So there's a lot of number of calls that we have to create internally, and no one is being hidden up over here, guys. We know that there's always a tussle between these teams always, and always the pain point, they will tell that there is a network latency that is being happening, and so only my application is not running. So I hope most of the guys might have gone those kind of calls. Okay, that's the pain point that we want to solve. We want to give developers a pretty easy hands-on on the ACI, that they can build the applications, they can build the networks accordingly to the applications. So obviously an application guys will be not able to understand what is the meaning and how to create a firewall configurations, how to write on the load balancer configuration. That's the easy task that is being provided from ACI. So if I'm going to give you some particular steps, you would be thinking that, yeah, that's a pretty easy one. We might be doing that one by creating a VLANs, applying a subnet, defining the firewalls. It's been a very long journey for me, but it's being always an easy task. Again, when you see the ACI GUI, it will be easy task for you. Now there's a question, if we are connecting firewall or server to a single leaf, how we will achieve high availability for the devices? Is it like we will configure VPC between leaves? The question is that, let me put that questions over here. Think about, this is the firewall, okay? Now, if this firewall is being connected to a single switches, I'm definitely telling this is not the high availability that we will try to achieve. Obviously, you have to put two connections to this very firewall and create a port channels from the firewall. So at least from the switch levels, you are being connected from two interfaces. So this is kind of VPCs that you would create from your end, and even from the switching levels also. Because from switches side, if I do have two switches, if I do have a device, I've been connected, I'm creating a port channel thinking that these two switches are same, but ultimately these switches will create VPCs. But remember guys, in this kind of set of VPCs, usually we would not require a peer link or peer keep alive kind of things. So VPC will be a little bit different in ACI. Doesn't require a set of config which might be doing in Nexus 7K or maybe Nexus 5Ks. But again, if you have to do the high availability from the firewall itself, like if this firewall goes down, how we would get connected to the another firewalls. So we can cluster two sets of firewall and telling that these two firewall will be responsible for an active traffics, or maybe the another firewall will be for the standby purposes. So the designs which I've just shown you, basically it was basically talking about the same stuff, how we are going to achieve the high availability. I think this is not the one. We had some different one. This is the one. Yeah, this is the one. So this is a dual host, how it's being getting connected. And that's the proper way. We should be able to only not connect to one single leaf. We should always connect it to the two leaves.
The communication between the firewall to leaf will be through classical Ethernet or through fabric VLAN. How it is?
Okay, actually the question is that, let me just put this one. Question is that if I do have a switches, if I do have a firewall, okay, if I do have a connectivities, okay, this is a basic port channels or whatever. The question is that, is it a classical Ethernet or is it going to be a fabric VLANs? That's the question. Yes. I must be telling it would be a classical Ethernet. Okay. You can have fabric VLANs, okay? You can have fabric VLANs in some specific firewall with Palo Alto, as far as I know. Okay. Because I've been working with one of the design cases with Palo Alto. They mentioned that they would be using some sort of fabric VLANs. But again, just to not confuse you guys, there would be a set of VLANs which we would be using in a fabric levels. Okay. Okay. But again, that's the one thing that we can still achieve. But mostly 99% it will be classical Ethernet.
Okay. Thank you.
No problem. So guys, that's the one thing, application language barrier. So that's being the one of the pain point. And if you see any kind of network diagram, how and a lot of things that we have to do. So traffic is being coming up, a lot of things that's been happening, a lot of number of VLANs that is being surpassing from one level to the another levels. And accordingly, we have to write on the configs. Now, whether we have to do those things when I'm an application guy, and obviously if I'm an application guy, I would be not able to do those things. We have to always rely on which team? Networking team. Like if I have to develop any applications, I need to always ask that networking team has not yet done, they have not created firewall, all those stuff. Okay, so it's always a pain point, and obviously the delivery of your applications will be getting delayed. That's the one thing. Okay, so that's the one stuff, like when we are doing any kind of changes, accordingly the policy has to be changed on our physical devices. But again, that will be again taken care by the ACI stuff. So what is an application to the network? Again, as I was telling, application is the collections of your all the endpoints when you do have VMs, when you have bare metals of a same family, like for the functionality wise from the application levels, they would be considered to be called as one set of EPGs. Okay, so on that very basis only, we are going to apply the networking policies to them. So this is just an overview, guys. When you do get any kind of infrastructures on whatever the levels that you do work, accordingly only try to visualize your traffic flows and even your workflows. So when an application guys see, they see the things in this very way. When a security guys will see, they just see zoning, not zoning, I should be telling zones, configurations. They would see how we are going to create firewalls, who would be DMZ. And when a network guys will see, they will see that what VLANs, what VXlan they have to configure. And cloud admin guys, they know how to run the different applications to them. Idea is that why don't we provide them a same GUI or same platform where they can do all this tasks with the help of APIC. So APIC is basically a management console to really have a hands-on on all this set of devices and applying your related policies as per your workflow models. So when an application guy is there, he can create and he can define what are the different applications that I'm going to run. Security guys, they will be writing the firewalls configs, and network admin guys will tell that what server is being getting connected to what switch ports. So accordingly, he would write on the configs. But what platform we are going to use? It's the APIC platforms. So we are going to create an operational framework in a internal infrastructures. But there has been like a lot of number of customers. They have created their own apps also. They have even created their own APIs also. And accordingly, only they try to run their operational things. Now, the ACI model does give you one another things. If anyone who's been coming up from the application development life cycles, or even like when you talk about the upgrade process, some of the companies will always have a test environment. Obviously, like when we go for any kind of upgrades, or whenever the application is being developed to test that things, we would not put that things purely on the production on the first day. We'll first of all try to test it, how it is behaving when we do have a huge traffic, how it is going to behave, what is the performance issues. So it's always tough for any particular customer to build these number of environment. So if you have to create that kind of set of replicas, it's always a cost thing. Okay, it's a very, very cost effective things. Now, really, when you talk about an ACI, we would try to achieve that things by creating the tenants. Like we would try to create three kind of tenants. Maybe there would be a dev model. So that will be one of the contexts that we would create. We would have test environment, and even we would have production environment. So we would be having three set of environment replicas to it, running on the same platforms. So on the top, they will have all set of same switches and spine and leaf switches, but their traffic will be always different to the traffic what is being created with the help of ACI's tenant. So whenever we talk about context in networking world, we always refer it as VRFs or maybe VLANs. But whenever we tell context in ACI, we will always refer to tenants. Like this is one tenant, maybe production tenant. This could be a dev tenant, and this could be a maybe a test tenants or developments, depends. Now, even we can also provide the same infrastructures to multiple customers. So customers calls can be also considered to be called as one set of tenants. So it depends what operational things that you're doing. Accordingly, you would be defining your related tenants. So the idea is that application models, how we can actually apply the same set of rules on different environment, like we do have dev, test, and production. If you have created the same models, remember the model I have created with the help of XML files, we can just keep on copying it, and we can apply our application development teams to develop the things in one different infrastructures. They could test it, and after the proper life cycles only, we are going to put them into the productions. So you need to really create a new environment all according to it. creating a new firewall, buying a new firewall, buying a new set of server, or buying a new set of switches. You can test in the same kind of infrastructures without giving any kind of blow what's been happening in the production environment. So this is again a very pain point. I hope this would be a very great thing that you might be experiencing with ACI. So I will welcome any comments if anyone has got, who have been coming up with these kind of infra. Like again, when I see other thing, upgrades is always again a pain point for the network guys. So whenever we upgrade, we have to always upgrade first of all test environment. If it has behaved very well, then only we'll go to the productions, right? Now I can't relate the upgrades very similarly how I have defined the application life cycles. Okay, but you can think about that set of environment. Why we do create test environment? Basically to test our application, how it is behaving, then only we'll put into the productions. But without investing a huge investment, we can still do that testing in the same environment itself. So that's the one another achievement that we can do with ACI. So that's being one of the first section, guys. I know that's being a very long theory sections. It's always a trouble to really understand a new technology, but I'm trying to give you the hypothetical way thinking, and then only we can head to the main stuff, like what are the major building blocks. So among them, the building blocks will be the Nexus 9000. But up to this moment, any comments, guys, any questions, then only we can move into the next sections.
Abhishek, what is the difference between APIC, like ACI environment of Cisco and VMware and NSX? So what is the similarities, or in some of the design, what I see, ACIs are integrated with NSC also and NSX. So could you give some brief description or difference between both?
Yeah, exactly. This is one of the very, very well used design by most of the customers nowadays, because again, when you talk about the SDN product line, VMware has got their own product line called NSX. Now there are a lot of number of advantages when you use NSX. Now there are some another set of advantage which you would find out with ACI. Now if I'll try to explain, they would be again like 2-3 days to really talk about on that set of design. But just to give you an overview on it, there's a great point that you have really came through, because I've been working with the design, and I'll tell you like 30 to 40% of design cases will be purely on NSX over an ACI. So this is basically an NSX over an ACI. Now it's not like that NSX will only run over an ACI, it can run on any over fabric. It could be even Junipers, could be Arista switches, can be anything. Because NSX only claims that I need to have just switches on the top, which can switch the traffic from one ESXi to the another ESXi. Now the idea is that when you do have your ESXi servers, now usually the ESXi servers we will design accordingly to the NSX basic design topologies. We try to create stuffs in this very way that we would be having a management cluster, MGMT cluster. Similarly, we would be having web cluster, we would be having app cluster, and maybe we would be having DB cluster. Similarly, there would be a cluster that is being called as an edge cluster. Now, idea of NSX is that they can do the routing on VMware levels, on a virtual levels. Because earlier, what they have to always do, like whenever they had to create a web network, similarly the idea 10.1.1.0/24 subnet, we have only reserved for the web traffics. App, maybe we have defined subnet of 20.0/24. Now, whenever a web VM has to talk to app VM, he has to send the traffics to whom? to the router. Okay, the router will send the traffic back to the app devices. This being done for a long time because VMware was mostly on the virtualizations. That was the server virtualizations. Now, what they came up with an idea, they came up with an idea called DLR, that is being called as a distributed logical routers. Now, idea is that why don't we put a router on every ESXi? Like on every ESXi, we would be having a routers. Now, what it's going to do, like whenever the web is going to talk to the app, the traffic will hit to the router, that is a local router, route that traffic to the app devices. If app is being sitting in the same ESXi, it has to not leave the ESXi and get back again. In that cases, the traffic will switch over within the ESXi's level. Usually these kind of traffic is being called as what? East-west traffics. Okay, like whenever we have to send the traffic from one tier to the another tier, east-west traffic. Even it's a very common term in the physical environment also. Now, to really do this kind of task, all these things is being happening at the back end with the help of VXlan. Because whatever the thing that we create as web, app, and DB tiers, they are being created as a port groups. But these are the DV port groups. But these DV port groups will be VXLAN capables. So that are the things that we are trying to achieve with the east-west traffics. But remember, when it comes to the traffic which has to really go to the internet, usually that traffic is being called as a north-south traffics. Okay, so whenever we have a north-south traffics, in that cases, we would be having edges. So edges is a concept again in the NSX. So edges are again like a VMs, which is only capable to send the traffics to the perimeter devices, which is being called as like your service provider, or maybe it could be the top of switches. So it's the top of row rack routers that you have to get it connected. So whenever these very VMs has to send the traffics to internet, mostly the web traffic has to get to internet, the edge devices is going to do that functionalities. But again, edge is not only for routing. This is going to provide you the firewall, microsegmentations, load balancers, IPsec VPNs, L2 VPNs, and many other functionalities. So a lot of things that you are now trying to achieve with the help of what? NSX itself. Even they do give you some other features like guest introspections. And even nowadays, like even NSX is being over on the AWS clouds also. So if you'll try to search VMware over AWS, that's also one of the features that you are going to get. But the thing that we are trying to talk about, all this VMware cloud is perfectly fine. That's fine. They need at least one fabric on the top. Because when it is a VM which is being a part of same ESXi, they can route the traffics. But when they are part of two different servers, it has to be a particular switches on the top. Now, switches, as I claimed that this fabric could be of any vendors, but when we go with ACI, we would be going to achieve the task, what we are going to get from the ACI also. So from the ACI, what we're going to get, whatever the redundancies that we get it from spine and leaf infrastructures, that's the one thing. And we see all these things as a bunch of a VMware cloud where we have to create a management traffic tenant, sorry, not tenant, EPGs. Similarly, we have to create a data traffic EPGs, and we have to create a edge traffics EPGs. So whenever we have any kind of a control center, this control center will try to get connected to your VC or NSX manager and many other stuff like your controllers and other stuffs, because still you would have the same kind of concepts of controllers in NSX also. So that will be our management networks. So that management network will be equivalent to your EPGs that you would create in your ACI side. Similarly, whatever the data traffic that is being going from a web app and DBs, that are all data traffic, which is being only for NSX specifically. So you can define a set of EPGs, and to really make that switch over of the traffic from one server blade to the another server blade, you're trying to provide a redundant path now. Not just like a single switch you are getting connected. You're providing an ACI environment which can actually utilize that features of ACI itself also. So though you're using NSX, so from a virtualization world, you're using the features of NSX, plus when it goes as a data traffic, you're using ACI as a features also. So if you have to apply some another set of security rules, you have to apply the redundancies rule or maybe load balancing rule, you can still achieve that things. And when it comes to edge traffic, like web traffic has to go to the edge. So edge is going to send the traffic as like a north-south traffic. So again, you have to create it as a separate set of EPGs. But again, as I was telling, it's not a small topic, it's a big topic, how you try to get it connected. But unless you don't have a great understanding on NSX and on ACI, at least you will not have the proper visualization on the design. But the idea is that how we can usually, occasionally we can use the features of NSX plus of ACI. That's the one thing that we are trying to achieve over here. Now, the other thing which you would find out with the ACI right now, this is the NSX cloud. Same way, we can even have Hyper-V clouds, right? Now for the ACI, the web which is being running in NSX and the web that is being running in Hyper-V, are you going to claim them as two different traffics or two different families? No, you're going to claim that these are web. Doesn't matter they are sitting on Hyper-V or some of these things are sitting on the VMware clouds. So we are going to represent all web as a single set of EPGs. So when I'm providing any kind of policies from an ACI level, so this ACI level policies will be even written on the VMware levels and even on the Microsoft levels also. So my policies is not different for Microsoft, not different for the VMware clouds also, because whoever are web, doesn't matter where they are sitting, I'm going to apply that same set of policies. But now think about the same set of things if you have to do in a multi-cloud or multi-vendor cloud. You have to always think about this feature is there in VMware, might be this feature is not there in Hyper-V. Vaguely there would be a major differences, but yeah, what we are trying to achieve from ACI is the same infrastructure builds. We are trying to apply the same sets of policies which is being distributed to all the devices in one single sets. So at least you got the idea what is the meaning of NSX over in ACI. I will be telling until you don't have a good understanding. All right, yeah. So unless you don't have the understanding more onto the NSX, because as like ACI is a proper bootcamp, similarly we take NSX bootcamps also. So these are two different technologies, but the things that we achieve with NSX is pretty much better what we do get with ACI. But again, ACI, what it is going to provide us, it can actually make a merging of two different clouds, which you would not see with NSX at this moment. Though like now they are claiming they would be coming up with NSXT, but at this moment they would be just going to provide services for ESXi and KVM. So this again a multi-cloud kind of concepts. Another good thing that they would be no any kind of vCenter integrations. At this moment, you have to really reluctant to the vCenters. So a lot of developments that's been happening. But one of the great things that's being really observed from VMware side is the VMware on AWS. So this is being called as SDDCs, software defined data centers. All right, guys. So that was one of the question, NSX over ACI. So I see people are being coming up with that kind of design a lot. But I must be telling like, I didn't find out most of the customers came up from India at this moment. Most of the cases we came up from Dubai, Middle East, from Australia, and mostly from Europe and US. But for India, I didn't find out that kind of design ever came up. Yeah, any other questions? There's another proper document for it if you want to see. That's NSX over ACI design guide. It's being distributed by Cisco. Even there's another community that runs for VMware. So this is the story from Cisco side, how these things will be achieved. And the similar kind of story would be given by VMware guys also. So you can see what are the different things they have created. All right. So guys, I'll not go further on. I think it's been a lot of number of theory sections today. Tomorrow when we'll meet up, we'll try to go with the physical switches, understanding what are the different Nexus 9000 switches, what is APIC, how we initialize that APIC, and how it gets started for the ACI configurations. So these are the topics that we are going to do that tomorrow. I'm not going to really to the high-end hardware properties. Obviously, you can research, and this properties is going to keep on changes as per the upgrades of the hardware devices. Mostly like this could be a support from leaf and spine switches level, and how you're going to see the controllers. So policy model, what is policy, and many other things. So let's stop over here, guys. I don't want to really give a big blow on the first day of class. Okay. I would give a recommendation, at least go with the white papers of ACI first and come up with a lot of questions. That's very required from the classes at this moment. I know there's a bunch of a lot of number of people are there. All right, so I think some of the folks I have already talked earlier.